Kia ora Year 12 and 13. This is the second video on the quadratic equation problem from the 2017 Calculus Scholarship paper. So the first video looked at how to solve this using the sum and product of the roots, and in this one I'm going to focus on what we know about the discriminant. Okay, so we've got this quadratic equation here, and it's got two real roots, and they're of equal magnitude, but they're opposite in sign. So we know that the roots of a quadratic equation can be written out like this. If the equation is in this form, then x is equal to negative b plus or minus the square root of b squared minus 4ac over 2a. But to generate two roots that are equal but of opposite sign, we know that we must have x is equal to 0 plus or minus all of this. So that means that b, our coefficient on x, is equal to 0. So we're going to start off by working with this. And the second thing we know is that because we've got two real roots, we know that the discriminant, b squared minus 4ac, must be strictly positive. But since b is 0, we must have negative 4ac is strictly positive. So what we're going to do now is we're going to rearrange the quadratic and then work with those two conditions. And our goal is to prove that bc over a is strictly negative. So the first thing we're going to do is to rearrange the equation. So we started like this. I've done this already in the other video, but just in case you have skipped that one, let's cross multiply and then partially expand. Now we're going to subtract everything from the right hand side as follows. Now we'll collect up like terms and we get our coefficient on x. Oops. Something weird's happening to my stylus. There we are. Okay, so that's all cleaned up now. Now we know from looking at the quadratic formula that b is equal to 0, and by b we mean the coefficient on x. So we're going to solve this. And we'll get b plus b plus ap minus a equals 0. So rearranging that, we've got p times a plus b is equal to a minus b. So p is a minus b over a plus b. So this is obviously overlaps massively with what we did in the first video. But there you go. So that's how far we've got so far. So remember what we've done is we've said that we've got equal and opposite roots. So b, my coefficient on x, is equal to 0. And we've worked with that, and that's given us an expression for p. Now the next thing we're going to do is we're going to look at the discriminant and what that means. Okay, so for two real roots that are positive, we must have b squared minus 4ac, strictly positive, but from above b equals 0, so negative 4 AC is strictly positive. And if you look back, I'm not going to write it out again. Oh, actually I can. It's very easy to write the quadratic out now. We're down to p plus 1 x squared minus c times p minus 1 because the x coefficient is 0. So we've got this. Let's have a look at negative 4 AC. Well, we've got negative 4 times p plus 1 times negative c times p minus 1 must be strictly greater than 0. So we have 4c times p plus 1 p minus 1 is greater than 0. So going back to my condition above, we've got a minus b over a plus b equals p. So p plus 1 is going to be a minus b plus a plus b, so that's p plus 1, which gives me 2a over a plus b. Now, similarly, what do we get for p minus 1? Well, p minus 1 is going to be a minus b over a plus b minus a plus b, right, and that gives me negative 2b over a plus b. So our last step is to substitute p minus 1 and p plus 1 in here. So we get 4c times 2a over a plus b times negative 2b over a plus b is greater than 0. That generates negative 16 ABC over a plus b squared is strictly greater than 0. I'm going to take a new slide to do this last bit because we just need to carefully work our way through. You can see that the end is nearly in sight. And remember, we're trying to get to this. BC over A is negative, so that's our goal. So we've got down to here. So negative 16 ABC over A plus B squared. And that must be strictly positive. ABC over ABC, A plus B squared must be strictly negative. That's dividing by negative 16. ABC must also be strictly negative since A plus B squared must be strictly positive because it's a squared number. And now I'm looking at it, I'm going, oh, where am I going to get an A in the denominator? So we're going to divide both sides through by A squared. And A squared's positive, so we can do that without changing the sign. And that leaves us with BC over A, which is negative, as required. Okay, so that's the second way to do the problem using the quadratic formula and the discriminant properties. Okay, so it all comes down to the fact that we've got two roots that are both real and of opposite sign but equal magnitude. And that means that we've got a quadratic parabola that has got this form, ax squared plus c. Thanks for watching. I'll do it Nicholas's way in about 10 minutes.